Alright, so in this video of my Physics with Calculus 1 series, we're going to be talking about projectile motion. So let's just begin with some few pointers and tips that are very important to stick to and remember. So the x component, so velocity's x component in projectile motion is constant, and the x component of acceleration is 0. And the y component of acceleration is negative 9.81 or sometimes negative 9.8, and it's constant throughout the entire motion. That's because of Earth's acceleration due to gravity. So let's just begin with an example. So we have a batter that hits a baseball at an initial speed, initial velocity of 37 meters per second at an angle of 53.1 degrees. So let's just go ahead and draw our free body diagram. So let's just establish our coordinate system. We have the y going up, positive y going up, and then the positive x going in the right direction. And so they tell us that at an angle of 53.1, so 53.1 degrees, the batter hits the ball at an angle, or at a velocity of 37 meters per second. So from this, we're given that the velocity, the initial velocity is 37 meters per second. That means that we have to go ahead and find the x component of this velocity and the y component of this velocity in order to continue on. And so the question is, we want to find the position of the ball and its velocity at 2 seconds. So when time is 2 seconds. So we want to find position at t is equal to 2 seconds. And so first we're going to dissect this initial velocity into velocity with an x component of this velocity and the y component of this velocity. And so this is our initial velocity. So it's usually denoted as v naught, which means initial velocity. And so v naught x is equal to, we could just use a little trigonometry. This is our hypotenuse, and the x component is this one right here, so it has to be the cosine. We're going to be using cosine, so that makes it 37 times the cosine of 53.1 degrees. And then if you go ahead and do it in a calculator, you get, let me see, so the cosine of 53.1, and then you multiply that by 37, you should get 22.2. So 22.2 meters per second is our initial velocities, or the x component of the initial velocity. And then we want to find the y component of the initial velocity, and that's going to be 37 times the sine of 53.1. And then once you punch that into the calculator, you should get, so 29.6 meters per second. Let me double check on that. Yes, alright. So now that we have, so the position, when we want to find the position, that means we want to find, the x position and the y position. It's like we want to find the coordinates of it. So let's just begin with the x. And then if you know, in one of our kinematic equations that we could use is that delta x is equal to the initial x velocity times time, and then plus a half ax, the x component of acceleration, times t squared. So to simplify this, we know that in projectile motion, the x component of acceleration is 0, which makes this entire thing 0, so we could cross that out. And then now delta x is equal to the initial x component of velocity times time. And then as you see right here, we have 22.2 seconds. 22.2, and multiply that by time. In this case, we want to find its position when it's 2 seconds in the air, so times 2. And then that would be 44.4. Therefore, delta x, or you could write it as x minus x naught, is equal to 44.4 meters. Alright? And now we want to find the y position after 2 seconds, and then same thing, except now we're going to have delta y is equal to v naught y times time, and then plus a half ay t squared. Okay, so the initial y velocity we said is 29.6, as you see right here, 29.6 meters per second, and then multiply that by time, which is 2, and then in this case the acceleration due to gravity, at least the y component, is negative 9.8, so negative 9.8 times a half is negative 4.9, and then multiply that by 4 because time squared, and then we should get, so 29.6 times 2 is 59.2, I'm putting equal, and then minus 4.9 times 4 is 19.6, and then once you subtract those two, y minus y naught should be 39.6 meters. Okay, and now the position would be x comma y, which in this case is 49.4 meters comma 39.6 meters. And we want to find the velocity at that moment, and then so the velocity would, you could use this other kinematic equation, which is, let's say if we want to focus on the x component velocity at 2 seconds, then it would be vx is equal to v naught x plus ax t. The x component of acceleration is 0, so we're left with vx is equal to v naught x, and then so the x component of velocity is equal to the initial component, the initial x component velocity, because as we said before, the x component velocity is constant throughout the entire motion, and so that makes vx equal to 22.2, same as the initial. Now when we want to find the y component velocity at 2 seconds, it would be same thing here, so vy is equal to v naught y and then plus ayt, and then v naught y we said is 29.6, and then minus has to be, so right here, so it's going to be 29.6 minus 9.8 times 2, and then when you punch that into the calculator, we should get 29.6 minus 19.6, and so velocity, the y component velocity, is equal to 10 meters per second. See, this is meters per second too, be careful.